Greetings to Prof. Madya Dr. Abdullah bin Haji Yassin and Prof. Madya IR Dr. Syed Tarmizi bin Syed Shazali. My name is Nur Adli bin Hatta, number matrix 62111, and my supervisor is Dr. Ana Sakura binti Zainal Abidin. Today, I'm going to present on my final year project KNJ 4214. My title for this project is The Development of NIPA Sub Cooking Stove for Industrial Purposes. This is the table of content for this slide, which will be includes introduction, literature review, methodology, result and discussion, and lastly, conclusion and recommendation. Firstly is the introduction for this slide, which consists of research background, problem statement, and objective. The research background for this study is the cooking of NIPA palm sap. The NIPA palm sap is one of the source for sugar, as its content was reported to be 14 to 17 sucrose. Sap is generally collected from the mature fruit stalk and boiled in a large cauldron filled with firewood. To add, sap production from NIPA produce and intoxicating beverages, sugar, vinegar, and alcohol that may be used as fuel. This is the problem statement for this project. It will be divided into 4 parts. Firstly, is the filthy cooking stove people use during the process of cooking the NIPA palm sap. The cooking stove usually is handled in an exposed outdoor environment. This will ruin the final taste of NIPA palm sugar. Not to forget, it will cause health problem to the consumer. Secondly, the traditional cooking stove is very time-consuming. It is required hours of boiling and only produce a low production rate for the NIPA palm sugar. Thirdly, the difficulty to obtain firewood supply. It is hard to obtain firewood at today's market because it requires energy, time, and labor in order to collect the firewood in the forest. Lastly, inconsistent cooking process. The inconsistent cooking process will affect the final product and build bad reputation among the consumer. Next is the objective for these slides. The objective will be divided into 3 parts. Firstly, to determine significant parameters that involve in an efficient NIPA syrup cooking process for industrial application. Secondly, to develop a SAP cooking stove to meet the certification requirement by MUSTI and Halal. Thirdly, to validate the developed cooking stove for industrial application. Second part of this slide is literature review, which consists of previous research and recommendations. There are 3 types of palm sap sugar available in the market. For the first type is sugar syrup. Usually, people boil the sap until certain level of brick content. It is then stored in the glass or plastic container. For molded sugar, people usually boil the sap until the very viscous sugar form. It is then molded inside a coconut shell or bamboo to form a hard sugar. And lastly is the powder sugar. For powder sugar, people usually heat the NIPA palm sap under agitation until sugar reaches supersaturation point. It is then formed a sugar crystal by cooling. Then, lastly, it grind and dry to acquire a standardized and specific powdered sugar. We will be focusing into the NIPA palm syrup. The NIPA palm syrup will get concentrated after few hours of boiling at approximately 110 degrees Celsius using an open tray on a wood-fired stove till syrup with suitable viscosity and color was produced. There are two types of fuel in today's market, which is traditional fuel and modern fuel. So this is the table for comparison between traditional fuel and modern fuel. Traditional or biomass fuel consists of woods, crop, manure, and garbage. The advantage of using this fuel is it is a renewable source of energy, cheap, and abundant in supplies. However, the disadvantage of using this fuel is it will lead to deforestation, high labor, uneven heating, and indoor air pollution. Then, for modern or clean fuel, usually is LPG, electricity, ethanol, natural gas, and solar. The advantage of using this modern clean fuel is it is cleaner compared to biomass fuel. Then, it does not produce ashes after heating, and no odor created until added. Then, for the disadvantage of using modern fuel is it is expensive and scarce. Table 2 shows principle for designing a stove. From the sources by Steele and Winiarski 2001, the finding is insulation through lightweight heat-resistant material around the fire. By Khan et al. 2016, the finding is keep airflow free by keeping the sectional area through the stove constant. Then lastly, by Kennygood and Nargahali, the first one finding is using of grate under the fire and the flow of heat is maximized to the pot with the right gaps. Certification for food safety means third-party verification that the food supply chain, product and processes follow an agreed. MESTI is an acronym which stands in Bahasa Malaysia for Makanan Selamat Tanggung Jawab Industry, or English for Food Safety is Industry Responsibility. Meanwhile, for Halal or Halalan Toyiban is as long as the products are safe, not dangerous, and permissible for use relative to Sharia law. The third part for this slide is methodology, which consists of flowchart, related parameters, development of NIPA pump set cooking stove, design of NIPA cooking stove, and lastly, simulation of design. This is the flowchart for this slide. For related parameters, there will be 4 parts. The first one is cooking method, then combustion efficiency, and then type of cooking fuel, and lastly materials. This slide will show the component analysis for NIPA pump set cooking stove. In this slide shows figure 4, interactional analysis for NIPA pump set cooking stove. Figure 5 shows the functional analysis for NIPA pump set cooking stove. This is figure 7, which is cause and effect analysis for NIPA pump set cooking stove. To improve the stove design by using TRIS analysis, the solution given by TRIS is firstly asymmetry, which is feature to improve temperature and feature to preserve is volume of stationery. The second one is using composite material, which is feature to improve is strength, meanwhile the feature to preserve is temperature. And then to improve pan design by using stress analysis, the first one is dynamic, feature to improve is temperature, meanwhile feature to preserve is productivity. Secondly is discarding and recovering. The feature to improve is loss of time and the feature to preserve is shape. Figure 7 shows the concept combination tree for Nipa palm-shaped cooking stove. Figure 8 shows the assembly drawing for Nipa palm-shaped cooking stove. Figure 9 shows the orthogonal drawing for Nipa palm-shaped cooking stove. Figure 10 shows the geometry of stove in ANSYS. Figure 11 shows the meshing of stove body in ANSYS. Figure 11 shows the setup condition of stove body in ANSYS. Figure 12 shows the setup solution of stove body in ANSYS. For the part of this slide is the result and discussion. Figure 13 shows the airflow at inlet of the stove body in ANSYS. Figure 14 shows airflow at outlet of the stove body in ANSYS. Figure 15 shows the path line of airflow through the stove body in ANSYS. Figure 16 shows the velocity magnitude inside the stove body in ANSYS. For the last part for this slide is the conclusion and recommendation. To determine significant parameters that involve in efficient Nipa syrup cooking process for industry application, it is fully achieved. The primary data for this is the dimension of Nipa syrup cooking stove and the supervisor advice. And the secondary data is the literature review and YouTube video. And then to develop a sub cooking stove to meet the certification requirement by MUSTI and Halal, it is fully achieved. The design a Nipa sub cooking stove inside AutoCAD and SolidWorks. And then the material used for the cooking stove are safe and clean. To validate the developed cooking stove for industrial application, it is partially achieved. Simulate the cooking stove inside ANSYS. And lastly, obtain result for airflow through the cooking stove body. This is the recommendation for this project. Firstly, increase the dimension of the Nipa cooking stove. It can allow us to produce more Nipa palm sugar. Secondly is increase size of air inlet to achieve complete combustion easier, which is blue flame. And lastly, design the air inlet unparalleled to each other. This will allow us to make air circulate longer inside the cooking stove body. That's all from me. Thank you for your attention.